In this session, we are going to understand how to value a bond when the cash flow becomes slightly complex, when the cash flow is not even and it is not evenly distributed. Then how would we value the bond? Till now, in the past session, we worked with very simple bonds, characteristics, where everything was perfectly aligned. For example, the bond was face value 1000, coupon 6%, coupon frequency annual, maturity 3 year, and effective interest rate annually was 7%. Now, the valuation of this bond is very simple because the cash flow and the discounting frequencies are perfectly matching. What if the cash flow and the discounting frequency or the effective interest rate doesn't match? Here, the effective interest rate is annual and the coupon frequency is annual. That's why you are able to solve the question. If it is annual, if the effective interest rate given is annual and the coupon frequency is semi-annual, then you wouldn't be able to solve this question even on pen and paper or BA2 plus calculator. And that is what we are trying to understand in this session, that how we can solve any valuation question where we have uneven cash inflows. Okay. So the reason you were able to solve this question, because if I create the timeline of cash inflow, then you will get 60 after 1 year, 60 after 2 year, and 1060 after 3 years. Now, what you have to do, you have to discount this 60 with 7%. So you'll discount it and find the present value of the 60 standing at 1 year by dividing it by 60 upon 1.07 raised to the power 1. This 60 is standing after 2 years. So when you will discount it, you will discount by 60 upon 1.07 raised to the power 2. This 1060, you will discount by 1.07 raised to the power 3 because it is standing after 3 year, right? Or in the BA2 plus calculator, you can simply put these key FV1000 PMT 60 N3 I by 7% compute PV, and you would be able to solve the question. Let's do that. Second clear TVM 1000 FV PMT is 60, I by Y is 7%, 3 is N, compute PV. This is the answer. So simple. But the problem is when the effective interest rate is annual and the coupon frequency is not annual, or if effective interest rate given is semi-annual and coupon frequency is not semi-annual. So I'm giving you two examples and try to solve this example at your own level first, and then you will understand the complexity. So I would recommend pause the video and solve these two questions. So example number one is the face value given is 1000, coupon 6%, frequency is semi-annual, maturity is 3 years, effective interest rate is 7%. I have changed nothing. The only thing I changed is semi-annual. Okay, you have to solve this question. So pause the video and solve the question, then you will understand what mistake you're doing. If you're pretty good with interest rate mechanics, this question would be super simple for you. So I'm saying it is compulsory for you. I'm saying it again and again. It is compulsory for you to watch interest rate mechanics session 1. Go to the YouTube channel, you will find this video. Solve this question, or you solve this question that the same bond, this bond, even this simple bond, in this simple bond where the interest rate is effective annual, coupon frequency is also annual. But instead of buying this bond at t equal to 0, when the bond got issued, you're buying this bond after 5 months. After 5 months. If you want to buy the bond after 5 months at this point, not at t equal to 0, then if you want to buy at 5 months, then what should be the price you're ready to pay? So the question is, you purchase bond one, the same bond, and you decided to purchase the bond after 5 months of the issuance, not at t equal to 0, at t equal to 5 months. At what price you should purchase the bond? If you're able to solve both the question, then you're pretty good with valuation and specifically you're pretty good with interest rate mechanics. So let's solve the first question. The problem with this question is that the frequency is semi-annual, the frequency of the coupon is semi-annual, and the effective interest rate is annual. There is a mismatch. So what you need to do, the first step is you have to find out the effective interest rate of semi-annual. That is me. That refers to that you need the effective interest rate of 6 month. If you can find out the effective interest rate of 6 month, then yes, you can solve this question. Because what happened? So if you try to project the cash inflow with the help of the characteristics, with the help of FV, frequency, coupon, and maturity given, then you'll find that the cash inflow would be 30 after 6 months, then 30 after another 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 6 months, and 1030. Now, when you try to discount this 30, you need the effective interest rate of 6 months. That is not given in the question. The effective interest rate of annual or yearly effective interest rate is given or provided, not the effective interest rate of 6 months. So to find the effective interest rate of 6 months, again, you have to watch interest rate mechanics. I'm solving it for you in this session, but it is going to be very superficial. So what we did in interest rate mechanics, we said that there are two paths. Path one is that you have 1 rupees or $1, you'll invest it for 6 months at an effective interest rate of 6 months, which you don't know, so assume it to be X. And then whatever happens, so it will become 1 plus X upon 100 into 1 after 6 months. Then you will reinvest for the next 6 months at the effective interest rate of 6 months. Then this will become 1 plus X raised to the power 2. Another path is you directly invest 1 rupees or $1 at 7% effective interest rate, which will become after 1 year, $1 will become 1 into 1.07. In both the path, whether it is path 1, we are investing for 6 months at an effective interest rate of 6 months, and then again the compounded value, again investing at an effective interest rate of 6 months. In both the path, this path and part 2, where you're investing $1 at 7%, which will become 1.07, in both the path, the final value should be equivalent. So that's what I have written. You will solve for this and you will get X is equal to 3.440804%, which is the effective interest rate of 6 months. If you're assuming that 7% is the effective interest rate annually, then the 6 month effective interest rate would be 7% upon 2. Then you are incorrect. It is incorrect. That's not the effective interest rate. And that's why you need to watch interest rate mechanics session 1. So now what I'm doing, I need to discount the cash flow which is standing after 6 months at the interest rate of 3.4408 raised to the power 1, which is standing after 2 6 months at an interest rate of 3.4408 raised to the power 2, so and so forth. So I'll discount this 30. I will discount this 30 by 1.034408 raised to the power 1. I'll first discount this 30 with 1.034408 for 6 months, and then again I will discount at t equal to 0. So that's why raised to the power 2. I'll discount this 30 first for the 6 month, and then again for another 6 month, then again for another 6 month. That's why raised to the power 3, so and so forth. Now your cash inflow timing and your effective interest rate is matching. That's why you can solve this question. Now you can also solve this question directly at BA2 plus calculator, but you have to be cognizant about two information now which will change. That two information is N and I by Y. So face value is 1000, it remained 1000. Coupon came to be 30, so PMT is 30. No brainer. But what is N? Going forward, N is not the maturity of the bond. Going forward, N is the number of cash inflow. Always. Not maturity. It is going to be number of cash inflow. How many cash inflow we have? 6. 1, 2, 3, 4, 5, 6. So it is going to be 6. What is my I by Y? I by Y is not going to be 7%. It is going to be the effective interest rate of the smallest tenure of cash inflow. Smallest tenure of the cash inflow. So what is the smallest tenure of the cash inflow? It is 6 months. So we'll write 6 months, right? But the effective interest rate of the smallest tenure, you don't have to write 6 months. You have to write the effective interest rate of 6 months. What is the effective interest rate of 6 months? 3.4408. Now solve this question. You would be able to find the correct present value. So let's do that. Second clear TVM, second clear work. 1000 FV PMT is 30. I by Y is 3 point, let's check, 3.4408. 3.4408 is I by Y. 6 is N. Compute PV. 976.5 976.466, 976.466, 976.466. If you have already achieved this value, then you are good with interest rate mechanics and you're good with valuation. Okay. Now, assignment. Assignment is instead of frequency, as in semi-annual, change it to quarterly. Change it to quarterly and try to solve this question. Okay. So this was example one. Still, the cash inflow were equidistant. The cash inflow was equidistant. This was 6 month, 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 this was 6 month. All the cash inflow were standing at equal distance of 6 month. But the next example that will solve, you will find that the cash inflow is not equidistant. Let's see. Now we'll take the simple example where the face value is 1000, coupon is 6%, frequency is annual, I by Y 7%, effective annual. Both of them are matching. Maturity is 3 year. But the complex part is you're not purchasing, you're not purchasing this bond at t equal to 0. You're not purchasing this bond at t equal to 0. You're purchasing this bond after 5 months. So here, you're purchasing it here and you want to know what should be the value of the bond here. So actually, the remaining tenure is what? 7 months. So it is 7 months. So now cash inflow are standing after 7 months, then 1 year, then 1 year. They are not equidistant. They are not 7 months, 7 months, 7 months. They are 7 months, 1 year, and 1 year. How would you solve this question? You cannot solve this question in any way on BA2 plus calculator completely. Yes, there is a trick to partially solve this question in BA2 plus calculator, but you cannot solve in BA2 plus calculator. You have to solve this question on pen and paper. So if the cash inflows are not equidistant, you cannot use BA2 plus calculator. The trick is, now see, the trick is first what you'll do, wherever you find equidistant cash flow, first try to discount those equidistant cash inflow at a point from where the uneven cash inflow starts, which means that you discount this 3 year cash inflow at t equal to 1 year. You discount that 2 year cash inflow at 1 year. First, you discount all the cash inflow at 1 year. Then you sum all the present value of the cash inflow and then you discount for 7 months with the 7 month effective interest rate. So you first discount this 1060 here and you can directly discount with the help of 7%. What you will do? You will do 1060 divided by 1.07 raised to the power 2 because this is 1 year and this is 1 year. You will discount this 60 with a rate of 7% only because it is only 1 year and the effective interest rate of 1 year is 7%. So 60 upon 1.07. You don't have to discount this one because this is standing at 1 year. So plus 60. So whatever the value you will get, actually, because there is a trick, I will use the trick on the BA2 plus calculator, but you have to solve it. I'm not going to tell you the trick right now. So the net cash inflow should be 1042. This is the cash inflow which is standing after 7 months from where you want to purchase the bond. So basically you have to discount this 1042 for 7 months at the effective interest rate of 7%. So if you discount this 1042 with the effective interest rate of 7%, then you will write 1.07 raised to the power 7 upon 12. And from where I'm getting this? I'm getting this from interest rate mechanics. And that's why I'm saying interest rate mechanics is the prerequisite of all the session that we would be doing going forward. 1.07 raised to the power 7 upon 12. And the final value will come as 1001.67. That is the present value of the bond. If, or this is the value of the bond you're ready to pay if you purchase this bond not today, but after 5 months. Now, what is this 1001.67? This is the value of the bond, or this is the price that you're ready to pay if you buy the bond not today, not on the issuance day, but after 5 months. At this point, after 5 months, not at t equal to zero, not at t equal to zero. So, this is the number line. This is 1 year. This is 2 year. This is 3 year. Today, the bond got issued in the market, but you're purchasing it after 5 months. What is the price you're ready to pay? Okay. Okay. So if you're able to understand and solve this question at your own level, then now you have understood how to play with uneven cash inflow and do the valuation. So with that, we'll pause here. In the next session, we'll try to understand how different characteristics of the bond impact the valuation. With that, I'll pause here. Thank you. Have a nice day.